Hey class, this video is on graphing exponential functions. We're just going to do very simple exponential functions so you get the idea of how to graph. So we have our parent graph, which is just f of x equal to b to the x power. Whenever the b value is greater than 1, that is an exponential growth function. For decay, same thing, but that's where the b value, our rate of change, is between 0 and 1. So I'm just going to give you an example of what it looks like and key features of it. So for growth, it kind of hugs the x-axis, but then increases super fast. In a simple growth function, it crosses through the points, always crosses through the y-axis at the coordinate 0, 1. And I'm just going to draw this here, the asymptote. I'm drawing this in blue. Hopefully you can tell that from the camera. This is our asymptote. And the asymptote is the equation of that line is y equal to 0. That is where the x-axis is. Okay. Decay, it's kind of mirrored. It's coming from very high and then going low. Constantly getting closer to the x-axis, but never reaching it. So it's also crossing through the y-axis at 0, 1. And I'm just going to write in. Right, that's where the asymptote is, also on the x-axis. Okay, before I get to these, I just want to mention is that y, the variable y, is the same thing as f of x. So y meaning is the output, f of x, we're going to plug in numbers, also going to be our output. Okay, so for our growth function, it's going to look something like this. We have f of x equal to 2 to the x power. This is greater than 1, so that's how we know that that is a growth function. That's going to model a growth function. How we graph is that we're going to plug in values. For our class, just something very simple is I always want you to plug in the values from -2 all the way to +2. Those are 5 numbers, right? -2, -1, 0, 1, and 2. We're going to plug that in for x. Typically, when you have a table, it's always x and then y. But the thing is, we just said that y is the same thing as f of x. But in here, I'm saying that f of x is 2 to the x power. So that's why we're just writing 2 to the x power there. Okay, so let's go ahead and I'm going to put 2 to the x power. But instead of x's, I'm going to replace them with the x's that we have on the left-hand side. So this is -2, this is -1, 0, 1, and 2. Okay, now as we simplify these are going to require a lot of understanding from exponent properties from previous sections. So 2 to the -2nd power, this is, or we want to represent powers as positive, so we need to put this in a fraction. You can think that putting it over 1. So I'll write it over here, 2 to the -2nd power over 1. The thing is, this has to cross the line, change the sign. It has to go in the denominator, so this will be 2 to the 2nd power, and 1 is in the numerator. And then simplify, this will be 1 over 4. So by plugging in -2, that is our x value. Our y value is our output. That is 1/4. So we'll graph that. -2, 1/4, that is 2 to the left on the x-axis, and 1/4 up, so it's not that much above the x-axis. Okay, next one, very similarly, we're going to put this over 1. But we have to make this, again, cross the line, change the sign. This will be 1 over 2 to the first, which is just 1/2. That ordered pair is -1 from our x-axis, and our output is 1/2. How we graph this is we go -1 to the left on the x-axis, 1/2 up, so in between 0 and 1 right there. Anything to the 0 power is always 1, so that was pretty easy. It is just 0, 1. And that's what we said on here on our parent graphs, is that it's always going to cross the y-axis at the coordinate 0, 1. Next thing is 2 to the first, simply is just 2. So this ordered pair is 1, 2. So that's 1 to the right, 2 up. And 2 to the 2nd power. So 2 times 2 is 4. That is 2, 4. So 2 to the right, 4 up. 1, 2, 3, 4. Now you're going to get these 5 points. Now as best you can is try to create a curve where this function it's not going straight up, even though it looks like that. It's constantly going to the right and up, so kind of angle it that way. And then this part going to the left of our function is going to kind of hug the x-axis. It will never get to the x-axis, but we're going to just draw it close to that. Okay, now let's get to our decay function. It's pretty similar to what we're doing, but we have a fraction in this case. Right, decay, this is where the b value is in between 0 and 1, and 1/4 is in between 0 and 1. So let's just go ahead and write this in before I apply our exponents. Now, you can plug in the numbers from -2 to +2, but it doesn't matter. You could plug in more numbers. I just use these numbers because it gives me a general idea of what the graph looks like. All right, we're going to put in -2, -1, 0, 1, and 2. Now, a property I'm going to write off to the side, you don't have to write this in your notes, is that when we have a fraction, I'm going to put a over b to the, we'll say m power. The m is applied to the exponent of both the numerator and denominator. So this becomes a to the m over b to the m. So we're going to have to keep that in mind with this. So we're going to have 1 to the negative second power over 4 to the negative second power. I'm just going to kind of go fast through this. Now, both of them are negative, so both of them become flipped. So we're going to have 4 to the second over 1 to the positive second. Now, 4 to the second is 16. 1 to the second is 1. 16 divided by 1 is just 16. So that ordered pair, -2, comma, +16. Let's go ahead and graph that. It will go off the graph, but let's just get an idea of where it looks like, or what it looks like. A -2, so that's 2 to the left, 16 up. So if you go 1, 2, 3, 4, 5, 6, let's go 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's somewhere up here. I'm going to write it in. Okay. Next one is we're going to apply this to be 1 to the negative first, 4 to the negative first. They're both negative, so let me circle them. Cross the line, change the sign, so this will be 4 over 1, which just simplifies to be 4. So that ordered pair, a lot easier, is -1, 4. So that's, I'm going to go 1 to the left, 4 up, 1, 2, 3, 4. Next one, again, anything to the 0 power is always going to be 1. So this is the easiest one, is going to be 0, 1 right over here. 1/4 to the 4th is just 1/4. Right, you're going to get 1 to the 1st, 4 to the 1st, it's just that. So that is 1, comma, 1/4. That means I'm going to go 1 to the right, and 1/4 up, it's very small, something like that. And maybe that's a 4th up, right? We're just estimating here. Now remember, you have to apply this exponent to both the numerator and denominator. So this will be 1 to this 1 squared over 4 squared. 1 squared is 1. 4 squared is 16. So this is 2, comma, 1/16. So 2 to the right. Now 1/16 is very small. That's like thinking of a pizza having 16 pieces. So imagine that, and then you getting 1 slice. So that's hardly anything. So I'm just gonna make it kind of really, really close. It's a little bit below this. And as best you can, it's gonna be hard to draw it. But I'm gonna draw this in red. Is draw the curve from this point down. Hopefully it doesn't look too bad. Okay, my art skills. Well, that was pretty good. So it looks something like this. It starts very, very high and then just goes down. Now, I want to give you an example for decay. It's like when we had our folding paper activity, right? If you fold a long sheet of paper in half, and then fold that in half, and that in half, and that in half. We're gonna get something that's really, really small, but the thing is, it will never be 0. That's why it never crosses the x-axis at 0. And that's why it hugs it. There's always some type of paper or some amount of paper that you can fold in half. All right, guys, that is the notes for this. Let me know if you guys got questions.